Nociceptive pain. Nociceptive pain occurs as a result of the activation of the nociceptive system by noxious stimuli, inflammation, or disease. Nociceptive pain proceeds through 5 phases: transduction, conduction, transmission, perception, and modulation. Nociceptive pain originates in the nociceptors, which are highly specialized primary sensory neurons found primarily in the skin or joints or the walls of organs. These receptors convert noxious stimuli into electrical current through a process called transduction. The current is then conducted along the nociceptor axons to their cell bodies, located in the dorsal root ganglion in the spinal cord, and then to their central terminals located in the dorsal horn. Here, the electrical impulses initiate neurotransmitter release from nociceptor central terminals, which relay the signal across synapses to the dorsal horn neurons. Greater stimulus intensities are associated with the release of neuropeptides, including substance P, from central terminals of C fibers. Substance P, acting via neurokinin receptors located on dorsal horn neurons, generates a greater postsynaptic response and enhances the activity of NMDA receptors. The signal is then relayed via ascending nociceptive pathways to higher centers in the brain, where it is perceived as pain. Ascending nociceptive transmissions are modulated by inhibitory or facilitatory control systems in the dorsal horn of the spinal cord. The process of inhibition and facilitation is regulated by neurons projecting from the nucleus raphe magnus in the lower brainstem. Nociceptive signals are transmitted through descending projections in the dorsal horn of the spinal cord. Facilitation serves to provide warning of tissue injury and encourages protective behaviors such as fight or flight responses, while inhibition may serve to provide analgesia at times of danger so that pain does not compromise function.